Hello everyone, my name is Avkash, and today in this short tutorial I'm going to show you how you could take the Walmart stores data and using the Plotly mapping library how you could render those maps. What you are seeing here is the heat map or the density map. We are going to learn this map. We are also going to learn how to render this scattered or the bubble map, and finally we are also going to learn that how we could render the hex map, all using the Walmart stores data. So let's get ourselves started. Get ourselves started for this project. What you really need is the data set and specific to the Walmart locations at US and the nearby US locations. Please visit to the data.world website, sign up and look for this Walmart data. And once you download this data set on your local machine, then you can follow up this project. For this project, I will be using the Google Colab. So in my Walmart data folder at Google Drive, I'm going to create a new Google Colab. This is my notebook. Import Pandas as PD, and at this point I have already downloaded this data set to my local machine, so I will be uploading this data set to this environment at Google Colab. So here is the root content, so upload, and here is the Walmart data set. That data set is uploaded and is available here. This is what I just call it Walmart equals pandas dot read CSV pd dot read CSV 6.csv. This is our Walmart dataset. You can see that this dataset is a collection of 4,654 location. wm.describe. It gives us all Walmart location at the map. Rest we do not really need it. So we can actually create a subset of this data set. So Walmart equals to Walmart and Walmart filtered data set. So we are interested in zip code. We are also interested in latitude, longitude. Remember, there are several other fields which are object or string are not listed in this describe. So these are the columns. So we have a name. We can use the location name, street address, city, state. We already got this here. Then we can use the country. So this is our limited Walmart data. Now it is much cleaner and targeted what we are looking for. At this point, if we would want to know how many unique states are there, so 52 states, United States, then we also have the Puerto Rico, and there should be one more included. Then if you would want to just look into all these unique records, you can say unique, and these are the states we have. So zip code, I'm looking into the total number of unique. So 4,177 unique record, where the total number of records are 4,654. So you could get an idea that there are some locations based on certain zip code. They have multiple locations. In this next step, we will group by our data. So we will create the DF, which is like a selected DF. So this is our column collections for the group by. So I think this should be perfectly ready now. So this DF is actually a group by data frame. So you see data frame which is group by. So we can look into the keys for this data set. So we can look into the size of this data set. We need to get this for every state in that city and then zip code. Maybe that's a better way to look into. So for a state, city, zip code, and the longitude and latitude. So that's even better resolution of our data. So these are the groups. So 4,653, because this is our grouped value. So we could say df dot, you can actually use the first, and it is like a selected. So this is, or if you would want to say df dot last, next we can say df dot groups dot keys. Even it's very limited data set we have with only selected field. So this, and then when we are creating this data frame, so it's going to be as index equals false, then whatever math we want to use the count, and then we can say dot reset index should be okay. At this point, the df should be the data frame, and as index, if we say index true, df index is there. Now if you would want to count per city, df city equals, you can select the df reset, that's the df city. So this is the count based on city. If you would want to create this based on state, you could actually create the state for here. You can say df state, and that value will be the state, and df state you can look into that as a count based on state. So each state here, and if you say true, that will be, this index will become the index. So now for each state you can get the count for each state, and here is a for city based count, so you got city and state based count. So if you would want to get more close resolution, we could actually take this longitude and latitude and reduce to a single precision. It means that we can put all these locations up to 11 kilometer area. So we are going to set up a precision. So let's use precision equals 1. So df dot latitude, df dot latitude, and we need to round it for the precision. Same thing we could do for df dot longitude and latitude equals df dot round precision. So now if we look into our df, you see that precision is set it up. It means that if we try to count, now we are going to be even better resolution. So we do not need city, we do not need zip code. So we could actually say that new df we have equals to df, and let's filter state. Then we also need the latitude, and we also need the longitude. So we have got, that's all. Now we can create the count here. So we can say all stores equals df dot group by, and then we can select the latitude, we can select the longitude, we can select the state. So after this we need to have the size dot reset index. So this is the all stores data. Let's look into what is all stores data. So count is added. Now we can change this to the store count. So we could say the all stores dot columns equal this, and then we can say store count. So this value which you see 0 will rename as a store count. So that became a store count. Now we have enough information so that we could actually generate our map data. To get the map data, I already have a project earlier. We need to go to Python projects, and it should be the Plotly Geo Maps. So here it actually shows how we can generate the heat map. We can also generate the hex map here, or this kind of map. So let's use this code because it will be super fast for us. So we need Plotly related modules for this project. So we are importing Plotly, NumPy, and MapBox token. If you do not have MapBox token, or this token does not work, please log into MapBox and get the new token. So now this environment is ready. Then we could use this density map first, and our data set will be this all stores. Longitude, latitude we already have. Store count will be this field. That's all. Longitude, latitude. Let's check, and that is our data. So we can look into, this is the data where if we would want to set this in center, longitude is negative 96.1, negative 96.1, and if we try to run this here, and oh sorry, zoom, we need to set zoom, maybe 3 will be perfect. So now here is all the data. If you would want to go a little bit more zoom, so that's where you are getting all the stores here in the Puerto Rico as well. So this map, you can see, if you would want to see this map also, we can build that map as well. Here our data set is all stores, longitude, latitude, not fire count. This should be store count, resolution because of data, but I hope that you get the gist of it. Let's try the third one too. Latitude, not the global fires. The data should be all stores, longitude, latitude, color, fire count. That should be the store count, hexagon, opacity. Okay. So we were able to create Walmart stores in US locations. So that was the objective for us. So you have the Jupyter notebook used in this tutorial is located at this GitHub repo, and the instructions to get the data set which is applied in this tutorial is available here. The another Jupyter notebook which we have used as the helpful article for this tutorial is available here. The rest of the information you can get from this README file as well as while watching this tutorial. So that's all we had in this tutorial. I hope you enjoyed it. It's a short but really very intense tutorial to show how you could render the any geolocation data, not only Walmart, to the Plotly maps. I hope you enjoyed, and thank you so much for your time, and I'm looking forward to see you in my next video. Until then, thank you so much.